Have you ever stared up at the night sky and wondered about its deepest, darkest secrets? What if I told you there are places in the universe where the laws of physics as we know them completely break down, places so dense, so powerful, that not even light can escape their grasp? Today, we are rediving headfirst into one of the most mind-bending mysteries of the cosmos. What's inside a black hole? To understand what's inside, we first need to know what a black hole is. Picture a star much more massive than our sun. For millions, even billions of years, it burns brightly, a powerhouse of nuclear fusion. But eventually, its fuel runs out. The outward push from fusion that held it up against its own immense gravity disappears. What happens next is catastrophic. The star collapses in on itself in a fraction of a second. This collapse is so violent, so extreme, that it creates an object with an almost infinite density packed into an infinitesimally small point. That, my friends, is a black hole. Now, let's talk about the anatomy of this cosmic beast. The first part you'd encounter is the event horizon. This isn't a physical surface you can touch, like the ground. Think of it more like the point of no return. It's the boundary around the black hole where the gravitational pull becomes so strong that the escape velocity, the speed you need to escape, is faster than the speed of light. Since nothing in the universe can travel faster than light, anything that crosses the event horizon is trapped forever. It's a one-way ticket to the unknown. So let's imagine we're on a brave, albeit hypothetical, journey. As we approach the event horizon, strange things begin to happen because of the intense gravity. If you were watching from a safe distance, you'd see my spaceship slow down, stretch out, and appear to freeze right at the edge of the event horizon, red shifting until I fade away completely. From your perspective, it would take an infinite amount of time for me to cross it. But for me, inside the ship, I'd sail right across the event horizon without noticing a thing. The point of no return would pass by in an instant. Inside the event horizon, though, things get really weird. For a smaller stellar mass black hole, the tidal forces would be immense. Gravity pulls much more strongly on the parts of my ship closer to the black hole than the parts farther away. This difference in gravitational pull would stretch my ship and me like a piece of spaghetti. This process has a surprisingly scientific, if slightly horrifying, name. It's not a pleasant thought, but it's what Einstein's theory of general relativity predicts would happen for a supermassive black hole, the kind found at the center of galaxies like our own Milky Way. The story is a bit different. Because they are so enormous, the event horizon is much farther out from the central point. The tidal forces at the event horizon are actually much weaker. So, in theory, you could cross the event horizon of a supermassive black hole without being immediately... You'd have a little more time to witness the bizarre reality inside. So, what would you see? Inside the event horizon, space and time do something incredible. They switch roles. On the outside, we can move freely in any direction. In space, up, down, left, right, but we are all relentlessly pulled forward in time. Inside a black hole, it's the opposite. You would be relentlessly pulled in one direction in space towards the center, and you couldn't stop it, just like we can't stop the flow of time. But you could, in theory, move around in time. It's a concept that completely warps our understanding of reality. All paths, every single trajectory inside the event horizon, lead to one inevitable destination, the singularity. This is the heart of the black hole. According to our current understanding based on general relativity, the singularity is a point of zero volume and infinite density. All the mass of that original collapsed star, or whatever else fell in, is crushed into this single, dimensionless point. Here, space and time as we know them cease to exist. The curvature of space-time becomes infinite. All the known laws of physics, general relativity, quantum mechanics, they all break down. They simply don't work anymore. So, what is the singularity really? Is it truly an infinitely small point? This is where modern physics hits a wall. The idea of infinity is usually a sign that our theories are incomplete. Most physicists believe that when we finally have a complete theory of quantum gravity, a theory that unites Einstein's general relativity with the strange rules of the quantum world we have a better answer. One leading idea is string theory. It suggests that the fundamental building blocks of the universe aren't points, but tiny, vibrating strings of energy. In this view, the singularity might not be a point at all, But perhaps a fuzzball, a tangled ball of these fundamental strings, all the information about what fell into the black hole wouldn't be destroyed at a singularity, but would be stored in the vibrations of these strings. So, in a way, you wouldn't be deleted from the universe, just rearranged into a very exotic form. Another fascinating idea is that a singularity could be a gateway to another universe. Some theories propose that the matter compressed at the center of a black hole could rebound and create a new Big Bang, forming a brand new baby universe. Could our own universe have been born from a black hole in a parent universe? It's a wild and speculative idea, but it's one that physicists are genuinely exploring. Then there's the famous information paradox. A key rule of quantum mechanics is that information can never be destroyed. But if you fall into a black hole and get crushed at the singularity, what happens to the information that made you? Your memories, your atomic structure, everything. Does it just vanish? Stephen Hawking famously wrestled with this problem. He proposed that black holes aren't entirely black. They slowly leak radiation, now called Hawking radiation, and over ions they can evaporate completely. He initially thought the information was lost, but later revised his theory, suggesting that the information might escape, scrambled and encoded in this faint radiation. The debate is far from over, but it's at the heart of our quest to understand the universe's fundamental rules. So, what's inside a black hole? The honest answer is, we don't know for sure. I bet science tells us there's a point of no return, the event horizon. Beyond that, space-time warps, tidal forces can stretch you into spaghetti, and all paths lead to the center. At that center is the singularity, a place where physics breaks down and gives way to mind-boggling possibilities, a fuzzball of strings, the birth of a new universe, or something we can't even begin to imagine. Black holes aren't just cosmic vacuum cleaners. They are the ultimate laboratories. They push the boundaries of our knowledge and force us to question the very nature of space, time, and reality itself. The quest to understand what lies inside a black hole is one of the greatest adventures in science. And with every new discovery, you get one step closer to solving this incredible cosmic puzzle. Thank you so much for joining me on this journey into the unknown. If you enjoyed this deep dive into the cosmos, don't forget to hit that like button and subscribe for more adventures through science. Let me know in the comments what cosmic mystery you want to explore next. Until then, keep looking up.